ancients found their fates etched in the heavens. Today's stargazer can follow the explosive lives and deaths of the stars themselves. Join us on a tour of the night sky. Next on Amazing Space. The sun shines on our rotating planet, its reflection skimming across the Pacific in this amazing sequence from space. It's this spin that creates the illusion of the sun's path across our skies. Earth's rotation also makes the stars turn gently above us each night. The combined spin of Earth and its annual orbit of the sun means that our view of the sun's position against the stars shifts by 4 minutes every day. As the seasons change, the sun traces a path through the background stars, a path called the ecliptic. Ancient astrologers strung figures along the line, forms suggested by groups of stars called constellations. The constellations of the ecliptic form what's called the zodiac, a pattern found even in the temples of ancient Egypt. Astrology and astronomy diverged long ago, but the constellations retain their mythical names. An unfocused photograph of stars reveals what our eyes cannot perceive. We see them this way, minus the subtleties of starlight. The stars have distinct colors, as an astronomical photograph or the view through binoculars will show. Good binoculars are the first essential for a new observer. Marked on every pair are numbers specifying magnification and lens size. These 10 times 50. The 10 indicates that this pair will magnify the image by a power of 10. The 50 is the size of the lenses, 50 millimeters. Here the eyepieces are marked 5 millimeters. That's the width of the light beam entering your eyes. The size you need depends on your age. If you're under 40, the pupils of your eyes will dilate to 7 millimeters. If you're over 40, they'll dilate less, just 5 millimeters. The more serious amateur observer may want to invest in a telescope with the help of a reputable telescope shop. This is a typical beginner's telescope, a refractor. For stability, it's mounted on a stand. A refractor gathers starlight through a large lens. The image is focused at the other end of the tube and magnified in the eyepiece. The amount of light gathered is what's important, not magnification. An alternative starter is this reflecting telescope. Again, it's the capacity to gather light that matters. Incoming light hits a mirror at the bottom of the tube. The light is bounced to a smaller mirror and reflected to an eyepiece on the side. A manual drive is a handy accessory for keeping a telescope on track, compensating for Earth's rotation. For a bigger telescope, you need a motor drive. Greater magnification needs finer tracking. When you begin your stargazing from the northern hemisphere, you'll want to start where Earth's axis points, northward towards Polaris, the pole star. From wherever you stand on Earth, only half the sky is visible. So Polaris appears lower and lower in the sky the further south you go. If you're at the equator, Polaris sits on the horizon. In the southern hemisphere, Polaris disappears altogether. Starting from Singapore, the south pole of the sky gets higher and higher the further south you travel. These are the stars of the southern skies, circling the south pole of the sky. Here, their northern counterparts, in long exposure. The Big Dipper is the place to start your survey of the northern sky. Ursa Major, the Great Bear. The two stars at the edge of the Dipper will point you to the pole star Polaris. Polaris is an Ursa Minor, also called the Little Dipper or Little Bear. A line through Polaris from the second star in the handle of the Big Dipper leads to the W of Cassiopeia. These two, forming the top of the Dipper, point to the star Capella, a brilliant point in the constellation of Auriga. This side of the Dipper points to another important star, Regulus. Regulus is in Leo the Lion. Finally, extend the handle of the Big Dipper around to Arcturus, a red giant star in Bootes, the herdsman, and then on to brilliant Spica. The first leg of your journey through the heavens.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
The glory of the Milky Way, our perspective and profile of the galaxy in which we live. An astronomical vista best observed when it's summer in the northern hemisphere and winter in the south. When our most powerful telescopes peer into clouds of gas and dust and the heart of our galaxy. They look fixed to us, but most stars are in motion around that galactic heart. But in the span of a human lifetime, they won't seem to move at all. The 200 billion stars of the Milky Way are all gently turning. One of them, our Sun, takes 200 million years to orbit the galactic center. If we could fast forward 10,000 years, the stars would reposition this way. As we look into the night sky, it's the point in Earth's orbit of the sun that determines our view. From this vantage, it's summer in the northern hemisphere, and towards the pole, the sun may barely set. But in the mid-latitudes, the sky looks like this, with the Milky Way stretching overhead. If you turn your eyes toward the north, these are the constellations you'll see in summer. Near the horizon, you'll find the bright yellow star Capella. Higher up in the Milky Way, you'll find the W-shaped constellation of Cassiopeia. Inside it is an invisible wonder, the radio signature of a star that exploded 300 years ago. Facing south, you'll see the rest of the Milky Way. On the far right, Corona Borealis, the northern crown. Next door, mighty Hercules. And top center, Lyra, the constellation of the Harp. Flying along the Milky Way, Cygnus, the swan. Below is tiny Delphinus, the dolphin. Also in the Milky Way is Sagitta, the arrow. Beneath that, Aquila, the eagle. To the left of the Milky Way, you'll find Capricornus, the sea goat. And to the right, Ophiuchus, the snake holder. Further right is the snake itself, Serpens. And lastly, at the bottom, Sagittarius the Archer, with a hint to the right of Scorpius. Turn your binoculars towards Hercules, top right. You'll find M13, a globular cluster of 100,000 stars. In Lyra, top center, is the bright star Vega. Brilliant Vega has a ring of dust, possibly a planetary system in the making. Lower in Lyra is the double star Shelliac. They can't be separated in a small telescope. They're so close they seem to siphon material from one another. Next to them in Lyra is M57, the Ring Nebula. A small telescope highlights a puff left over from a star that exploded hundreds of thousands of years ago. More difficult to spot is the Cygnus Loop, debris from another ancient explosion. But the Hubble Space Telescope shows the shock wave is still racing through space. Here's its position in Cygnus. Shift your binoculars lower in the Milky Way to Sagittarius to see a cosmic showpiece. M27, the Dumbbell Nebula, is the shroud of a slowly dying star. Moved on again to Aquila and the bright star Altair, just 16 light years away. Altair spins so quickly it bulges. If you live further south in the northern hemisphere, in Florida, for example, the summer constellations look like this. Sagittarius is now well clear of the horizon, and beneath you'll find Corona Australis, the southern crown. The whole of Scorpius is visible to the right. Turn your binoculars here above Sagittarius and you'll find M16, a cluster of stars in the Eagle Nebula. 2 million years ago, they formed from the gas and dust that still surround them. This central region of the Milky Way abounds in splendor. We're scanning the vicinity of Antares in Scorpius, a vast nebula, a cloud of dust and gas 5 light years across. Thousands upon thousands of stars. Towards the galactic center, in this case a picture from Australia. Optically, the view of the center is blocked by dust and gas. Other ways of peering into it present a cosmic conundrum. This radio image suggests a cloud pattern caused by a star-devouring black hole. But the infrared image shows huge stars undisturbed at the galactic center. The heart of our own galaxy remains a mystery.
Amazing Space will return on TLC. Amazing Space now continues on TLC.
In its annual orbit of the Sun, Earth approaches an equinox. It's late September, autumn in the northern hemisphere and spring in the south, the time of the year when days and nights are equal the world over. This is the season to study galaxies. The night sky faces outwards, away from the distractions of our own galactic center. Exotic stars and wondrous clouds adorn the celestial stage. In the southern skies can be seen the Small Magellanic Cloud, a satellite galaxy to our own Milky Way. We know about the nature of stars and galaxies because each one radiates a distinct spectrum of light. In the region of Orion, for example, here are 4 major stars and their spectra: the cosmic fingerprints of Rigel, Sirius, Procyon, and Pollux. Astronomers can compare the spectrum of a star with a laboratory scale. Where the lines match up, certain elements exist. From light years away, we can tell what a star is made of. Spectra can also reveal which way something is moving. Light shifts towards red if a body is retreating, and towards blue if advancing. It's known as the Doppler effect. In the case of galaxies, stars moving toward us have a blue shift. Those moving away from us are red shifted. The autumn sky in the northern hemisphere. First, let's reorient the familiar northern constellations. The Big Dipper, or Ursa Major, is low in the sky. Gemini, the twins. Auriga, the charioteer. Perseus. Cassiopeia, the queen. Cepheus, the king. Hercules, left over from summer. Draco, the dragon. And Ursa Minor. At the center of things, as always, is Polaris. Let's go back down to the 7 bright stars that form part of Ursa Major, also known as the Great Bear, the Big Dipper, and the Plough. One of the 7, Mizar, has a companion, so close it was used as an eyesight test in armies of old. Through a powerful telescope, Mizar is not 2 stars, but 3. The larger companion is Alcor, too far from Mizar to make the pair a true binary, but the smaller one qualifies. We see the sky in 2 dimensions. If we could travel around the 7 brightest stars of the Big Dipper, we'd see that the constellation is an illusion. In 3 dimensions, their distances from each other as well as from us are very different, far from the picture they present to Earth. And the stars themselves are moving. In about 100,000 years, the 7 stars will realign to look something like this. If we reverse the process by traveling back in time, they'd form another configuration. The patterns we see today are like a single frame in a movie. The cosmos is ever-changing. This is how the 7 stars would have appeared 100,000 years ago, more like a spear than a dipper. Turn and face south in autumn, and these are the constellations you'll see from the northern hemisphere. Delphinus is still around from summer, the great square of Pegasus, the flying horse. Straggly Andromeda, the chained maiden. The 3 sides of the triangulum. Just beneath, Aries the ram, and the 2 fish of Pisces. Lower down, the sea monster Cetus, sometimes called the whale. To the west, Aquarius, the water bearer. And finally, the sea goat Capricornus. Up here in Andromeda, you'll find the most distant object visible to the naked eye. This great galaxy, also called Andromeda. It's a spiral galaxy like our own, with over 300 billion stars, plus a couple of satellite galaxies. The Hubble Space Telescope took a close look at this satellite galaxy, M32, in the early 1990s. From the clarity of Earth orbit, Hubble peered into its heart. Each dot is a star shining like a sun, emitting light that takes well over 2 million years to reach us. Low in the sky, through binoculars, you'll see a faint blur. A big telescope reveals the magnificent Helix Nebula, a cloud of dust and gas expanding at some 25 miles per second, a dying puff of energy from this central star, whose corpse will be a white dwarf. High in the sky, between the Triangulum and Andromeda, the faint galaxy M33. Visible in binoculars, M33 is one of the best full-face spirals in the sky. We're still looking south, but from the lower latitudes of the northern hemisphere. Low in the sky, you'll see the constellation of Piscis Australis, the southern fish. Here is the star Fomalhaut, with an exciting possibility. Recent evidence suggests that it's surrounded by a cloud of cool gas, the kind of cloud that gave rise to the planets of our own solar system. Five billion years after our own beginnings, a new set of worlds may be taking form. Protoplanets reminiscent of our own Earth and its neighbors. Molten spheres, cooling perhaps, will one day provide a foothold for new life in the universe.
We'll bring you a stargazer's guide to the heavens above us, season by season, as the Learning Channel's journey through amazing space continues next.